our planet, a blue marble suspended in the vastness of space. We've charted its continents, explored its mountains, and even reached for the stars. But beneath the waves, a world of immense mystery remains, the Hadal Zone. These are the deepest trenches, the abyssal plains, the crushing depths where sunlight fails to penetrate and the pressure is almost unimaginable. Welcome to the realm of the ocean's darkest secrets. For centuries, these depths were thought to be barren, lifeless voids. The sheer pressure, equivalent to having dozens of elephants standing on a single square inch, seemed insurmountable. But as our technology advanced, we began to glimpse the extraordinary life that thrives in these extreme environments. This is a journey to the bottom of the world, to explore the deepest places on Earth. Our journey will take us to some of the most remote and challenging locations on Earth. We will examine the science behind these unique environments, delve into the history of their exploration, and meet the remarkable creatures that call these dark depths home. First, let's define our terms. The ocean is divided into zones based on depth and sunlight penetration. The epipelagic zone, also known as the sunlight zone, is closest to the surface where most of the visible light exists. The mesopelagic, twilight zone. Below that is the bathypelagic zone. Beyond that lies the abyssal zone, a vast, cold, and dark realm that covers a significant portion of the ocean floor. But even deeper than the abyssal zone, from roughly 6,000 meters, 19,685 feet, to the very bottom, lies the Hadal Zone. Named after Hades, the Greek god of the underworld, it's a truly alien environment. The defining characteristic of the Hadal Zone is, of course, the immense pressure. At the bottom of the Mariana Trench, the deepest point on Earth, the pressure exceeds 1,000 times the standard atmospheric pressure at sea level. To put that in perspective, it's like trying to breathe with the weight of a small car pressing on your chest. This extreme pressure presents a formidable challenge for life. The Hadal Zone isn't just one continuous abyss. It's composed of deep-sea trenches, narrow and elongated depressions in the ocean floor, formed primarily at subduction zones where tectonic plates collide. These trenches are scattered across the globe, but the majority reside in the Pacific Ocean. Each trench is a unique ecosystem shaped by its geological history and geographic location. Subduction zones are dynamic and active areas. As one tectonic plate slides beneath another, it creates immense geological forces. These forces not only carve out the deep trenches, but also trigger earthquakes and volcanic activity, further shaping the Hadal environment. Segment 2. The Mariana Trench, Challenger Deep, and beyond. The undisputed champion of deep-sea trenches is the Mariana Trench, located in the western Pacific Ocean, east of the Mariana Islands. Within this trench lies the Challenger Deep, the single deepest point on Earth, reaching a staggering depth of approximately 10,929 meters, 35,853 feet. That's deeper than Mount Everest is tall. The first human beings to venture into this extreme environment were Jacques Piccard and Don Walsh in 1960 aboard the bathyscaphe Trieste. Their journey was a testament to human ingenuity and courage. Imagine the sheer anxiety as they descended for hours, encased in a steel sphere, unsure if their vessel could withstand the crushing pressure. Their brief time on the bottom yielded a profound discovery. Life existed, even in the Challenger Deep. They reported seeing a flatfish-like creature, a simple observation that shattered previous assumptions about the limits of life. Decades later, in 2012, filmmaker James Cameron made a solo dive to the Challenger Deep in his submersible, the Deep Sea Challenger. His expedition captured stunning visuals of the trench floor, revealing a seemingly barren landscape, but also collecting valuable data and samples. Cameron described the experience as surreal and isolating, but also deeply moving. He was struck by the silence and the sense of profound solitude. More recently, the 5 Deeps expedition, led by Victor Vescovo in the submersible limiting factor, successfully reached the bottom of all 5 of the world's deepest ocean trenches. This expedition provided an unprecedented opportunity to study the Hadal Zone, collecting samples and documenting the life forms that inhabit these extreme depths. Vescovo and his team discovered new species, mapped previously unknown features, and even found evidence of human pollution, highlighting the impact of our actions on even the most remote environments on Earth. These explorations have shown the Challenger Deep is not a lifeless void. Scientists have discovered xenophytophores. These single-celled giants can grow up to 10 centimeters across. Amphipods, scavenging crustaceans specifically adapted to withstand the intense pressure. Snailfish, a newly discovered species of snailfish adapted to pressure and cold. The key question is, how can life possibly exist under such extreme pressure? The answer lies in remarkable adaptations at the molecular and cellular level. Hadal organisms have evolved unique strategies to cope with the crushing forces. One crucial adaptation involves molecules called piezolites. These specialized molecules stabilize proteins and cell membranes, preventing them from collapsing under pressure. They essentially act as tiny shock absorbers, allowing biological processes to function normally. Many Hadal creatures are also smaller in size and have simpler body structures. This reduces the surface area exposed to the intense pressure. They often lack swim bladders, which would be crushed at these depths, and have more flexible skeletons. Another important adaptation is the ability to thrive in the cold, dark environment. Hadal temperatures are typically just above freezing. Many deep-sea organisms have slower metabolisms, allowing them to conserve energy in this resource-scarce environment. Bioluminescence, the production of light by living organisms, also plays a crucial role in communication, attracting prey and evading predators. The anglerfish, with its bioluminescent lure, is a classic example of deep-sea adaptation. But many other creatures, from jellyfish to bacteria, use bioluminescence to navigate the darkness. The Hadal Zone is a testament to the incredible adaptability of life. These organisms have evolved in isolation for millions of years, developing unique solutions to survive in one of the most extreme environments on Earth. Studying them provides insights into the fundamental limits of life and the potential for life to exist elsewhere in the universe. While the Mariana Trench holds the title of deepest, it's just one of many Hadal zones around the world. The Kermadec Trench, located northeast of New Zealand, and the Tonga Trench, its neighbor to the north, are both incredibly deep and relatively unexplored. The Japan Trench, off the coast of Japan, and the Philippine Trench in the Western Pacific also present unique challenges and opportunities for scientific discovery. The Kermadec Trench, for example, is known for its abundance of amphipods and other scavenging crustaceans. Scientists have also discovered unique species of sea cucumbers and brittle stars in this trench. The Tonga Trench is particularly interesting because of its intense geological activity. It's home to numerous hydrothermal vents, which spew out superheated water and chemicals from the Earth's interior. These vents support unique ecosystems of chemosynthetic organisms which derive energy from chemicals rather than sunlight. These organisms are often bacteria or tube worms. Hydrothermal vent ecosystems are oases of life in the deep sea. They demonstrate that life can thrive even in the absence of sunlight, relying on chemical energy from the Earth's interior. Exploring the Hadal Zone requires advanced technology designed to withstand the crushing pressure and navigate the dark, unforgiving environment. Submersibles are a central tool for deep-sea exploration. The Alvin, operated by the Woods Hole Oceanographic Institution, is a long-standing submersible that has contributed to many deep-sea discoveries. Remotely operated vehicles, ROVs, are unmanned robots connected to a surface vessel by a cable. This allows scientists to explore the deep sea without risking human lives directly. Autonomous underwater vehicles, AUVs, are pre-programmed to carry out surveys and collect data without direct human control. These are valuable for mapping, monitoring environmental parameters. The development of new materials like specialized alloys and ceramics has enabled the construction of stronger and lighter submersibles capable of reaching the deepest parts of the ocean. Advances in underwater imaging technology have allowed scientists to capture high-resolution images and videos of deep-sea creatures and landscapes. These cameras are designed to operate in low-light conditions and withstand the immense pressure. Sonar, sound navigation and ranging, is commonly used to map the seafloor and detect underwater features. Multi-beam echo sounders provide detailed bathymetric data, helping scientists create accurate maps of the Hadal environment and identify potential areas of interest. Acoustic communication systems allow submersibles and ROVs to communicate with surface vessels and transmit data in real time, facilitating collaborative exploration and efficient data collection. Our exploration of the Hadal Zone has revealed a disturbing truth. Even the deepest parts of the ocean are not immune to human pollution. Plastic waste, microplastics, and other pollutants have been found in the Mariana Trench and other deep-sea trenches. The presence of plastic in these remote environments is a stark reminder of the global scale of the pollution crisis. Plastic debris can harm deep-sea organisms through entanglement, ingestion, and the disruption of their habitats. Microplastics, in particular, can accumulate in the food chain, potentially impacting the entire ecosystem. The Hadal Zone is a fragile and vulnerable ecosystem. We need to take urgent action to reduce plastic pollution and other forms of pollution that threaten these unique environments. We also need to establish marine protected areas to safeguard these deep-sea habitats from destructive activities like deep-sea mining. Deep-sea mining, the extraction of minerals from the deep ocean floor, is another potential threat to the Hadal Zone. While it could provide valuable resources, it also carries the risk of habitat destruction, sediment plumes, and the release of toxic chemicals. Careful regulation and environmental impact assessments are crucial to ensure that deep-sea mining is conducted responsibly and sustainably. The exploration of the Hadal Zone is still in its early stages. As technology advances, we can expect to see even more sophisticated submersibles, ROVs, and AUVs capable of venturing deeper and exploring more extensively. New sensors and imaging systems will provide unprecedented insights into the physical, chemical, and biological characteristics of the Hadal environment. The Hadal Zone holds immense potential for scientific discovery. It could reveal new species, new metabolic pathways, and new insights into the origins and evolution of life. Studying Hadal organisms could also provide clues about the potential for life on other planets. The future of Hadal exploration is incredibly exciting. We are developing new tools and techniques that will allow us to explore these depths with greater precision and efficiency. Our goal is to unlock the secrets of the Hadal Zone and understand its role in the global ocean system. The deepest places on Earth are a testament to the power of nature and the resilience of life. They are a reminder of the vastness and mystery of our planet and the importance of protecting these fragile ecosystems. As we continue to explore the Hadal Zone, we will undoubtedly uncover new wonders and gain a deeper understanding of our place in the universe. The Hadal Zone is not just a remote and inaccessible realm. It is an integral part of our planet, and its fate is intertwined with our own. Let us continue to explore, to question, and to protect the secrets of the deep for the sake of knowledge, for the sake of our planet, and for the sake of future generations.